I've written SOHCAHTOA over there. Now, what do I have? I want you guys to tell me in the chat, what two things has this triangle given me? Okay, in relation to my triangle, I know that I have this 45-degree thing, and I've also got this thing. What do we call this part of my triangle? And over here. Anybody remember? That's it, Rita. That's it. I have got my 45-degree angle, and I've got my hypotenuse, right? What do I want? What is it that I want? What do I want in relation to my angle? What is this side that I'm actually looking for? What is it called in relation to my angle? That's it. Ooh, Rita, you are on fire. That's how we get 70%. We are just killing it. All right, Liabona, remember it's the one right next to my angle, therefore it is my adjacent. Okay, so what I actually have is my adjacent and my hypotenuse. Now, Nicole, remember, if my 45-degree angle is sitting here, the side right next to it, that is my adjacent side. Next door, my adjacent side. Okay, remember, the one right next to it. The opposite one is always going to be the one furthest away from it. This one is my opposite side. But we don't have anything for my opposite side, so we don't have that. Okay, now tell me, guys, I've got an adjacent and a hypotenuse. Between SOH, CA, and TOA, which one of these uses adjacent and hypotenuse? SOH, CA, or TOA? That's it, Amy, the CA. And the C in CA stands for cos. So we're going to go cos of theta is equal to adjacent over hypotenuse. Right, and then I can go cos of, do I have my angle theta? Yes, I do. My angle theta is 45 degrees, is equal to my angle, my adjacent side, which is x. I almost said A, it's x. Okay, x over my hypotenuse, which is 17. Okay. Now, if I want to get rid of 17, I'm going to multiply this side by 17. And then I'm going to have to multiply this side by 17. And the reason for that is because 17 divided by 17 will give me 1, and I can isolate x. So I can then go x is equal to 17 times cos 45 degrees. And then I'm going to pick up my best friend, Mr. Calculator. And therefore, x will be equal to, give me an answer, guys. What is x equal to? Punch that into your calculator. I'm going to tell you in just a bit. We're still doing sides and angles, Michael. We're still doing sides and angles. Okay, Dogozo says it's 12,02. Click, Rita, click the SD button for me. Okay, I know it's complicated. It's probably got like √3 + 2 over 2, something weird like that. Just click the SD button for me, and the answer will come out as 12,02. All right, so this is a bit of a recap of what we did on Monday. Now, for those of you who are joining us for the first time today, we are actually on lesson 4 of 6. We're on lesson 4 of 6. So if you're a bit confused as to what is happening, because at your school you haven't done trigonometry yet, that's okay. What I need you to do is I need you to go and watch lesson 1 and 2 and 3. Don't leave. You can do that after this class. But for the time being, stick with us. I'm going to try and explain as slow as possible so we can understand what's happening. And then we're going to continue from there. Oh no, Chloe, I'm so sorry. Amy says, should our answer always be in a decimal? Not always. Okay. And we're going to be talking about special angles very soon. So I'm going to show you instances where we don't need a calculator. All right. Hi, Kioratile. It's okay. It's awesome to have you with us today. All right. Now, the last thing we spoke about on Monday before we left, we spoke about the cousins, the long-lost cousins of sine, cos, and tan, cosec, sec, and cot. No worries, Lisanda. So I want to see if we have a brave soul who doesn't mind putting their hand up and telling me what was cosec of theta equal to again? What sec of theta is equal to, and what cot of theta is equal to. Oh, Rita, you're awesome. Let's see. Michael, no. Rita, do you remember what is cosec again?
I'll try. Cosec is 1 over sine theta.
That's beautiful. That's it. Yes, 1 over sine theta. And sec is
1 over cos theta.
Good, and then, yes, because sec looks like cos backwards. Yes, that's it, cos theta. And then cot is the only one with a t. The other one with a t is 1 over
tan theta.
Beautiful. Just molto bene.
Yes.
I don't know. I don't speak Italian. I'm going to stop now. Okay. Thank you. Thank you, Rita. You did that so beautifully. So beautifully. Hi, Samuel. Nice to have you with us. Okay. All right. So we're going to try this and put this into our calculator quickly. Now, this is cosec of 40 degrees. This should be degrees. Degrees. We're only going to do these first three. All right. So cosec of 40 is the same as 1 over sine of 40 degrees. So I want you to go to your calculator, type in 1 over, you can even click that button that has a square over a square, 1 over sine of 40, close bracket, don't forget to close brackets, click equals and give me an answer. Thanks, K, that's it, and I believe that is the correct answer. Beautiful, this is 1,56. I know. Michael, what is math without a calculator? Hi, hello Takato and Nsako. It's awesome to have you guys back with us today. All right, let's look at cot. Remember, guys, cot is 1 over tan. So we're going to go 1 over tan of 210 degrees. And I'm going to remind you now, okay, that I'm going to remind you now, guys, that in this particular one, okay, we're not going to get, you don't need to click SD. Just give me the answer exactly the way it comes out. Okay. Give me the answer exactly the way it comes out. Okay. Don't click SD. Just give me the answer. It's the square root of something. Ooh, Takato, if it's giving you a maths error, that means after you put 210 in, you didn't close the brackets. Your calculator does that. Close the brackets and then it'll give you an answer. Good. It gives us the square root of 3. Okay. Hey. In a case like this, do not click SD. Okay, leave it as the square root of 3. But if it's really complicated, yeah, maybe, or if it gives you the answer in a decimal, leave it as a decimal. But if it gives you the answer as square root of 3, leave it as square root of 3. Okay. All right, let's do this last one over here. Sec 62 is equal to 1 over cos of 62. Teacher Nels, can you please DM Sige and ask her what her calculator looks like at the top, if you know what I mean? Okay, thank you, Sige. Teacher Nels is going to have a conversation with you, and the answer for this one should be 2,13. All right, give me a thumbs up if this is your first lesson and you don't understand what's going on. Yes, Amy, I think that would be best. Most teachers will just cancel the answer they don't want and mark the right one. Okay, I hope your teachers are nice like that. That's what I would do. I would cancel out the wrong answer and mark right the correct one. But I don't know, other teachers are finicky. So if you leave it like this, they're most likely to give you the mark. Okay, that is the general rule in mathematics. Okay. All right, can I get a thumbs up from everyone? Do we remember the cousins? Do we know how to use them? Are they easy? Give me a thumbs up, guys. All right, I quickly just need to try and switch on the lights and see if they will switch on. I will be with you guys in a second. In the meantime, I want you guys to look at cot. Remember, this is 3 cot of 65 degrees. Remember, we said we're going to rewrite this one as 3 times 1 over, remember what cot means, and then this is a fraction, so treat it as a fraction, and then this one over here, guys, is 2 times 3 times 2 over 3 times 1 over something, degrees. All right, I will be with you guys in just 1 second.
Sihle, I just sent you a DM. Can you please just go to chats? Arisha, do you have a question? Is it now fine, Sihle?
Hello.
Hi.
Hello.
How are you?
Oh, do we have a question? Go for it, teacher. Now, do you want to take this one?
Hi, Arisha.
How are you?
I'm good for yourself.
I'm good. It's my first time in this class, so like I don't know nothing about trig, so that's why I'm a bit confused.
Oh, but we have like 3 lessons. Do you want to
Okay.
take? I mean, we have already done 3 lessons on trigonometry. They are available on our website and the classes. So if you have time, you can just go through the website and watch those lessons and be up to speed.
Okay, no problem. Thank you.
Okay.
Thanks so much, Teacher Nels, for that. And Teacher Nels, do we have the link to those?
Yeah, I
somewhere
can
on the website.
Yeah.
Okay, thank you so much. Okay, Arisha, don't stress. I understand it looks like people are saying funky things in the chat when you get here, but we've started this from the very, very beginning. So the people who are getting all the answers right know exactly what's going on because they've been with us since lesson 1. So if you're not understanding, you can just, in the back of your mind, you can just go, yeah, it's because I wasn't here. So you guys can't judge. We won't judge you. Don't stress. Okay. All right. Okay, I'm seeing some funky answers. Mirula, I don't know about the word dum-dum, but yes, we all didn't know anything at the beginning. We all learned from the beginning, yes. Okay, so I'm gonna get 3 divided by 1 times tan of 65. And Arisha, if you're having a bit of trouble with this, have a look on your calculator. These sine, cos, and tan things are on your calculator. So you're just gonna make sure you put brackets around this on your calculator, otherwise it's gonna give you a problem, right? Okay, this first one over here, remember when we multiply fractions, guys, we're gonna multiply the top and multiply the bottom. So I'm actually gonna get 3 over tan, because 1 times tan is just tan of 65. Okay, which is equal to, I'm seeing everybody say 0.72. Is that the correct answer, Teacher Nels? I'm just gonna confirm with you. Or is it 1.40? I think it's 1.40. 1.40, yeah. All right, 1.4. And then over here at the bottom, I'm going to get sec, which is 1 over cos of 22 degrees, which is equal to, then we're going to have 2 over 3 cos of 22 degrees, which is equal to, I'm seeing everybody say 0.72. I hope that is correct. Teacher Nels, is that okay? Just a nod from you would help me. Yeah, okay, excellent. Okay. All right, okay. So this is what we did on Monday. So for those of you who are still confused about the cousins, they're not actually called cousins in trigonometry, guys. They're called reciprocals. We just call them cousins so that we can remember who they are. Okay, they're not called cousins. Ah, okay. Nicole says, I don't know if it's my calculator, but it's giving me math error. Remember, Nicole, your calculator is going to do this. It's going to go cos, and then it's going to open a bracket for you. And then you're going to type in 65. The one thing you need to do before you click equals is you need to close the bracket and then click equals. Otherwise, your calculator is going to continuously give you a math error. Okay, that does happen. Close the bracket. Takato knows very well. Okay, these are called reciprocals, guys. Okay, not cousins. We just call them cousins so it's nicer and easier to forget. Okay. I know, Michael, I know. Okay, it's just easier to remember than the word reciprocal. Yo, that's a long word. All right, let's talk about things on a diagram again. All right, so we're going to be using the same idea. Pablo says, does sec equal cos? No, it equals 1 over cos. Okay. Sec 62 is equal to 1 over cos of 62. All right, you need to put it in your calculator as 1 over. Thank you, teacher Mills. All right, okay, so we're going to do the same thing that we did last time, guys. Here is my right angle triangle. I'm going to make this side equal to 3, and I'm going to make this side over here equal to 5. And I'm going to put this over here as theta, as theater, or theta, as the Americans say, theta. All right, now let's look at what we actually have in relation to our angle. I have this side. What is this side called, guys? Tell me in the chat. This side is called the opposite. Thank you, Oguhle. That's it. It's called the opposite. Okay, Mulisa, don't put your hand down. I want you to help me finish this question. Okay. And what about this nice looking side all the way over here? The opposite to my right angle triangle is called my longest side. That's it, Leobona, beautiful. My hypotenuse. Excellent. Mulisa, how are you, my dude? Unmute for me. Let's have a conversation.
Hi, ma'am.
How are you doing?
I'm good. I wanted to answer the question, so.
Yes, no, let's answer the question. We're not done. We're not done. You're still going to help me. All right. Tell me, Melissa, what information do I have? What information do I have? I have my which sides?
We have our hypotenuse.
Have a look over here. What's this? Good.
Yeah.
I've got my opposite side and my hypotenuse, right?
Yeah.
And what am I looking for? The question says find theta. What is theta exactly? What are we looking for? Theta is? What does theta stand for? What is theta actually in place of? What would I replace theta with?
Not
I'll
sure.
give you a hint. It comes in degrees. It comes in degrees. What is it?
Angle.
Yes, it's an angle. Or according to Christina, an angel. Yes, an angle. Good. Now, Mulisa, do you remember? We have a funky thing on our calculator that we need to click every time we're looking for an angle. What do we need to click on our calculator when we're looking for an angle?
Where's my
There's a button. There's a button that we need to click before we click sine, cos, or tan. What is that button?
shift? Huh? Shift.
Ooh,
No.
Shift. Yes, it's shift. Sorry, I didn't hear that correctly. It's shift. You're absolutely correct. We need to click shift, my dude. Okay. Now, Mulisa, we're not done. Tell me, between saw, car, and tower, which one uses my opposite side and my hypotenuse side? Between saw, car, and tower, which one has O and H?
It's car. It's up. Yeah, car. It's a car. Yes, it's car.
It can't be car, because car has an A, and I need something with an O in it.
Oh, it's saw. Opposite of
Yes,
hypotenuse.
it's saw. Yes, it's opposite of a hypotenuse. Good, because I have my opposite and my hypotenuse. So if I write this out, Melissa, I'm going to go sine of theta is equal to opposite over hypotenuse. Right. Good. But Melissa, I'm actually looking for my angle today. Yes?
Yeah.
So I'm going to click on my calculator. I'm going to go sine theta is equal to, how much is my opposite side?
Wait, can I?
My opposite side is
It's
how
3.
much?
3.
Good. 3 over, how much is my hypotenuse?
5.
5. Good. Now, if I want to find my angle, what am I going to click on my calculator?
Shift sin.
Good. I'm going to go shift of sine, and this is going to come up sine of -1, and then a bracket. And then what do I put into that bracket?
3 over 5.
Good. 3 over 5. Don't forget to close brackets. And then tell me, what does your calculator say? Because that's going to give us our angle. Therefore, theta is equal to
36,86. But if you're rounding off, it's 36,87.
Okay, good. Yes, that's what I want. 36,87. But I'm calculating for an angle. So what should my answer be in? 36,87? What's the unit for angle, for an angle? 36,87 what?
36,7. Wait, let's see.
Look in the chat. Look in the chat. Everybody's helping.
Degrees. Oh, degrees.
Degrees, yes. Angles are measured in degrees. Do not forget. Okay. 36,87 degrees. Okay. Let me see if I'm getting this right. Is it Huera? Yes, Huera. Okay, why is there a negative 1 over sign? Huera, I want you to go to your calculator and I want you to click the shift button and then click sign and tell me what your calculator does. Okay. Tell me what your calculator does. Your calculator will put the -1 in for us. Okay, and we call that arcsine. When we pronounce it, we call it arcsine. Takato, I'm loving that. Amy, you guys are the best. I want us to encourage each other as Watobians to make sure that we're all doing the right thing. Okay, let's try another one. Okay, let's try another one. Okay, we can't get beat out by trig, guys. It's not that difficult. Not difficult at all. All right, the instruction is still find theta, but now this is the information I'm going to give you guys. This side over here is equal to 12, and this side over here is equal to 35. I want a volunteer. Anybody? Come on, y'all. Somebody? Anybody? Notando or Notando? Not Notando. Notando, how are you?
I'm good, and you, ma'am?
Hello, Notando.
Hi, ma'am.
Excellent, thank you, my sweetie. All right. Tell me, my sweetie, what side do we call this side? The side right next to my angle.
Ma'am, we call it adjacent.
Good, it's my adjacent side. So I've got an adjacent side, and this side opposite my right angle triangle is called?
The hypotenuse.
Excellent. So what information do I have? I've got my adjacent and my?
Hypotenuse.
Excellent. Now, between saw, car, and toa, which one uses adjacent and hypotenuse?
Car.
Car, excellent. So what does the C in car stand for?
Cos.
It stands for cos. So I'm going to get cos of theta is equal to adjacent over hypotenuse. Now, I want you to finish the sum for me. All right. If I go cos of theta is equal to what's my
12
adjacent over my hypotenuse? Give me a number.
over 35.
5. Beautiful. We did that beautifully. But now, Notando, I actually want my angle theta. So what do I need to click on my calculator?
Shift.
Good. So I'm going to go theta is equal to arc cos. Click shift on your calculator, my sweetie.
Yes,
And then
ma'am.
it will open, my calculator will open a bracket. And then what am I going to put over here?
12 over 35.
Beautiful. Close bracket.
Yes, ma'am.
Click equal and give me an answer. Therefore, theta is equal to
69,94, but when you round it off, it's 69,95
95 what?
degrees.
Degrees. Oh my gosh. Like you did that in less, Notando, you did that in less than a minute. I'm just so impressed. So impressed. I knew you could do it. That was just,
Yeah.
don't make me speak Italian again. My Italian sucks. But you're excellent. You're amazing. Well done.
Thank you, ma'am.
Very, very well done, my sweetie. Excellent stuff. All right. Jasmine, what's up, my sweetie?
Hi.
Hello, my sweetie. What's up?
Does the answers always end up as a decimal?
Most of the time, yes. Okay. Sometimes not, because if you punch this into your calculator, if my opposite side was 1, if my opposite side was 1 and my hypotenuse was 2, if you click shift sign of 1 over 2 for me, what are we going to get as an answer? Shift sign of 1 over 2 is? How much is it? Have you managed? Or have I lost Jasmine?
No, give me 1 second, please. Starting 30.
No worries. It's 30. No decimals. Do you see that? It's just 30 degrees. Okay. So some of them come out nice and beautiful, like 30 degrees. Okay, but because some of the numbers are a little weird, we're not always going to get such nice looking stuff. Okay?
Okay, thanks.
All right, guys. Can I just get a thumbs up from everyone? Thumbs up. Are we understanding what's happening? Do we know what we do? For those of you who are joining us for the first time today, it's okay if you're a little bit lost. If you watched last Monday's episode and last week's 2 episodes, you'll understand a little bit better. Akwando says, my professor told us to always keep it as a fraction because we won't be allowed to use the calculators for tests and exams. Yes, Akwando, but in your case, your teacher will be talking about things such as special angles. And we're going to talk about special angles because you're going to have to know your special angles without using a calculator. So next week, Monday's lesson, no calculator. Okay, no calculators will be allowed. Hi, Nicole.
Hi.
Hello, my sweetie.
How are you, ma'am? So,
I'm good, thank you. Yes.
How do you spot the difference? How do you know that this side is high, this one is opposite, and this one is adjacent?
Okay, so we always need to look at our angle, okay, Nicole? If my angle theta is down here, the one right next door to it, that's called an adjacent side, okay?
Yes.
We call that adjacent. And then the one very far away from it, the one furthest away from it, that's called opposite. And this long side, remember you did right angled triangles in grade 8 and 9 by Pythagoras? Yeah. This long side is always called the hypotenuse. Okay. So they already come with the names in them. Okay, so Nicole, tell me quickly. Okay, I'm going to switch these around quickly. Okay, let's do this. If I put my angle theta over here, this side, the one right next to my angle, what would this side be called? The one right next to? It starts with an A. It's called adjacent. Okay.
Okay.
This one is called adjacent. The one furthest away from it over here, what is this one called? Can you finish that word? It's called the opposite.
Opposite.
And this one, the one that's always opposite our right angle, this long one, is called?
The hypotenuse.
Beautiful. It's called the hypotenuse. Okay, so it's important for us to remember these things when we're doing these kinds of questions. Okay.
Okay.
Excellent. It takes some practice, but remember, Nicole, we are 3 lessons in. So you're joining us halfway, which means everybody else who's been with us from the beginning already learned this in the lessons before. So if you want to help, if you want to understand this better, I need you to go watch lesson 1. Go watch lesson 1 and lesson 2 and lesson 3. Okay, I feel like a YouTuber. Watch episode on this next episode of this. Okay. All right. Go watch lessons 1, 2, and 3. And I can see many people saying good luck to Samuel. Good luck. Okay. Fingers crossed. I know you don't need it because you're excellent, but we're going to give it to you anyway. Okay. You see, Takato, I love that. Takato says, we were all lost when we first joined, but we managed to understand. It's not a crime not to understand, guys. We'll all figure this out in the end and nail trigonometry. You know what, Takato? Like, you're my whole hype, man. My whole party. I need to invite you to every party because, guys, we're going to get this. And I know you guys see it. Oh, Arisha, good luck. Okay, if you need help with some of this stuff, or if you're not doing this yet, I'm sure your teacher is still doing equations and things like that. We also have videos on our website about equations, so you can go have a look at those. Okay. All right, guys, let's do some practice. Here are 2 questions that we're going to do together. All right. Now, this side over here, this is my theta. Remember, the side right next to it is called something. And this side over here is called something. And then you guys have to think about, what do I have and what do I want? Okay. When you guys have found the answer, pop your answer in the chat for me. All right. Lihle, I have a feeling that hand is to answer the question. I'm going to need you to have your calculator in your hand because we're going to need it. We are going to need it. Okay. Alicia's like, can I get Watobe light? Alicia, you're doing great every time you're with us. I think you're over-exaggerating because you're doing quite great. Lihle, how are you doing, my sweetie?
I'm good, and you, ma'am?
I'm excellent. All right. Tell me, what do I have?
Unfortunately, ma'am, this question, it's a question, not an answer, ma'am.
Oh, okay.
Better luck next time, ma'am.
Okay, what's up, Lihle?
Okay, ma'am. For the previous question, they asked us, we said sin, and then we press the shift button, right? And then say sin, and it will give us sin to the power of 1, right? And then I put the within like the fraction 2 over 1, right? And then I close
1
the bracket.
over 2. Remember, sign is O over H. So the opposite side was 1 and the hypotenuse was 2. If you put 2 over 1, it was going to give you a math error because we can't get anything over the value of 1. So you should have went shift sign of 1 over 2, close brackets, and then that would have given you 13.
Oh, I see.
Aha. So what you did was hypotenuse over opposite instead of opposite over hypotenuse. Okay.
Thank you.
All right. All right. Just be very careful with that, Lihle, but I absolutely get you. All right. I'm seeing everybody doing this for me in the chat. I see you guys. Excellent. Many of you have said, oh, Rita's going to do this one with me. Yay. All right, Rita, let's talk. Do you want to unmute for me? Hi, my sweetie.
Hi, ma'am. May I please see the answer? Or like explain?
Yes, absolutely. Tell me, what do I, you can't just give me the answer. You must tell me the steps. You need the steps. All right. All right. What do I have?
So, we have the hypotenuse and adjacent side.
Excellent. We've got hypotenuse and adjacent. What do we want?
The angle.
Excellent. And every time we want the angle, what do we need to click?
Shift.
Excellent. We need to click shift. Good. Which one? So, car, or Toa?
Car.
I've got, yes, car, because I've got adjacent and hypotenuse. Good. So give me a formula. Cos of theta is equal to?
A divided by H. A over H.
A divided. Good. That means that cos of theta is equal to, give it to me in numbers.
Cos of theta equals 8 divided by 17.
Beautiful. And if I want theta, I'm going to write theta is equal to?
Cos to the power of -1. And then in brackets, divided by
in brackets
8 divided by 17.
Good. Close brackets. Don't forget to close brackets. Therefore, theta is equal to
61,3. Oh, sorry. 61,93.
Beautiful. 61,93. What?
Oh, degrees.
Degrees. Beautiful. I'm sorry. I just I almost choked myself there, but Rita, very well done.
Thank you.
Very well done. Excellent. Ooh. As I 100% die. Okay, no, I'm still alive, guys. Don't worry. All right. Kay, you're telling me what the next answer is. I want you to put your hand up and help me with it. Can you? Alicia's like, breathe air. I'm trying. Alicia, I'm trying. My body's giving up on me. I don't know. Wow, Gift is already wearing a mask. That time it's a virtual classroom. Literally, it's over the interwebs, but Gift is wearing a mask. Hi, Liabona.
Hi, ma'am. Can I
Hi.
answer
All
the
right, let's
next
do
one?
this one together. All right, tell me, what do I have and what do I want? What do I have in relation to my angle? By the way, this is my angle.
We have an
I've got
adjacent,
excellent, and
hypotenuse.
and what? Good. I have my
Hypotenuse.
adjacent and my. What do I want?
We want the angle or theta.
Good. And what am I going to click? If I want the angle, I click
We
on my calculator. What do I click?
We'll click shift.
Shift. Good, because we call it. Yeah, it's a shift angle, guys. Don't forget shift angle. Shift for the angle. Shift angle. Good. So what is my which ratio am I using? Sine, cos, or theta?
We will use car.
Good, car, which stands for cos of theta. Did I just say sine, cos, or theta? I meant sine, cos, or tan. All right, cos of theta is equal to?
Adjacent over hypotenuse.
Adjacent over hypotenuse. Excellent. So cos of theta is equal to, give it to me in numbers.
Cos of theta is equal to 13 over 18.
13 over 18. Excellent. All right. Now I want theta. So I'm going to go theta is equal to?
We'll shift cos.
Excellent. Which is arc cos of?
Oh, and you plug 13 over 18.
Excellent. Close brackets. Don't forget to close brackets. Therefore?
Yes. Therefore, theta is equal to 43,76 degrees.
Beautiful. Liabona. Excellent. Well done. Well done. Very, very nicely done, my dude. Excellent. And because I can already see what's happening in the chat, I want Zamanzini and Amy to put their hands up. Arisha and Nicole, were you guys able to follow that process? And were you guys able to put that into your calculator? You see, I told you. One day we didn't know, and now we know. And now we know. Beautiful. Excellent stuff. All right. Amy, one especially for you. Especially for you. Here we go. I'm very glad, Arisha. That's exactly what we want. Hi, Amy.
Hi, ma'am.
How are you doing?
I'm good, and yourself?
I'm excellent, excellent. So this is my theta over here. What do I have?
Ma'am, we have our adjacent side and opposite side.
Good. And we have our opposite side. Beautiful. So I've got adjacent and opposite. What do I want?
Ma'am, we want our theta, our angle.
Good, our angle. And when we want our angle, what do we click?
Shift.
Shift angle. Yay, that's it. Shift. All right. Between saw, car, and tower, which one uses opposite and adjacent?
Tower, ma'am.
Tower. And what does the T in tower stand for?
Tan.
Tan. Good. So we're going to go tan of theta is equal to opposite over adjacent. Give it to me in numbers, Amy. Tan of theta is equal to?
34 over 39.
Beautiful. All right. But now I want theta. That's going to equal to?
10 to the power of -1, bracket 34.
Over?
39.
Good, over 39. Close brackets. Therefore, theta is equal to?
41,08.
08 what?
Degrees.
Degrees, yeah. See, this is why sometimes, Amy, I don't pick you because I don't do it 100%. Just everybody, beautiful.
Yes,
very beautifully done.
Thank you,
very, very well done. I think so that I don't insult any more Italians, I need to start learning Italian. I need to start learning Italian so that I don't start swearing at people in Italian.
Michael,
I'm fine, guys.
consent.
I know Michael's like, man is dying. Guys, what are we gonna do? Our math. Oh, gift, you must put degrees because there's a difference. This is a length, and if you don't put degrees, they're gonna assume that it's a length. So you must put the degree sign, okay? Excellent. All right, I want you guys to have a look at this one quickly. I'm gonna do it very quickly because we are a bit out of time, and I want to do a very, very quick intro to what we're gonna be looking at on Monday. Okay, I am. Zanogute, remember how I fought you about therefore? I'm going to fight you about degrees. I'm going to fight you. Okay, all right. So over here, I'm going to look at what I have and what I want. Now, if this is my angle theta over here, the thing all the way on the other side of my angle, this is my opposite side. And this long side over here, 90 degrees, opposite to my 90-degree angle is my hypotenuse. You guys can tell me in the chat, which one am I going to use? You can already tell me in the chat what I'm going to use. I've got opposite and hypotenuse over here. Okay, that's it. And what do I want? I want my angle. And I automatically remember that I need a shift angle. It's a shift angle. All right, so we're going to use SAW. And we know that the S in SAW stands for sine of theta, which is equal to opposite the hypotenuse. Okay, so I'm going to put this in numbers. Sine of theta is equal to, my opposite side is 51 over 54. Theta will then equal to arc sine, or sine to the -1, as you guys call it, of 51 over 54. And therefore, theta is equal to 70,81 degrees. Guys, please give me a thumbs up in the chat. How are we feeling about everything that's happened here? Yes. I do. I mentioned the word therefore. Therefore, do not forget the therefore. I love it. I love it. Arisha, I'm loving that you're with us. Samuel's like, ma'am, add some spice, ma'am. It's boring, ma'am. It's too easy. I can feel it. And that's why I've got the next section lined up. Hi, Komuto. Akwando, you need to explain what that emoji means because Komuto, I'm seeing that your hand is up, and that's why I'm saying hi. I thought you would unmute and ask a question. Hello, Komuto.
Hi. Hi, ma'am.
Do you have a question for me, my sweetie?
No.
Oh, okay. Did you have your hand up because you want to answer a question?
Yes, I wanted to answer a question.
Okay, my sweetie. Okay, so we've actually come to the end of today's lesson, but I'm going to introduce something new. So can I ask you to hold on to that answering a question for me for Monday? That means you have to come back Monday, hey? You have to.
Okay.
Okay?
Yes.
All right. Thank you so much for being willing to put your hand up. I want you to put your hand up, Komuto. Okay, it's not over. Alicia would think. Samuel, here is the spice that we were hoping for. We're going to move to the Cartesian plane. All right. Okay. Now, guys, let's do a bit of a shake because we're going to do some serious math. Come on now. Come now, Nkululeko. Stretch. I see you. Yeah. Okay, let's do it. All right. It did. Didn't you hear it? It snapped. It went. It absolutely snapped. All right. So here's what we're going to do. We're very used to the Cartesian plane. We know that this is X and this is Y. Now, we're going to learn something a little new. Okay. We're going to pretend that we've taken our protractor and we've used our x-axis as the part of our protractor. So we're going to use x over here as 0 degrees. Okay, so now if I had to measure on my protractor, guys, the angle from here to there, what would the y-axis over be here if I put my protractor on there? How much would it be? Yes, Blandila's like, ma'am, are we doing the cost diagram? Yes, we are. We are. It would not be 180. Remember, Zamanzini, this would be a there'd be a square down here. So what would y be up top here? Yes, Jasmine?
90 degrees.
That's it. Yes, it is. Actually, don't go away, Jasmine. This is 90 degrees. What about over here? On this side over here? Over here.
Over there where the dot will be 180, isn't it?
Yes. Yes, it's 180 degrees. Excellent. Now, what happens if I go all the way down here? Over here. What part will this be?
So, 360.
Oh, 360 will be back at 0.
Okay, 270 degrees.
Yes, it's 270 degrees. And then you agree with me, hey? 360 degrees will be back here where 0 is. Are we in agreement?
Yes.
Because it's a full revolution, and a full revolution is 360 degrees. Good. So 0 and 360 are gonna share this. Okay. Excellent. Jasmine, thank you so much for that, because that's exactly what I was hoping to hear. All right. Thank you very much, my sweetie. Okay, so here's what I'm gonna do, guys. I'm going to draw a dot. Okay, I'm gonna draw a dot over here. And I'm gonna write it like a coordinate plane. I'm gonna do this. I'm gonna go 4 and 3. Right. And I know that you guys have seen this before on a normal coordinate plane. What does the 4 stand for? What does the 4 stand for? What value? That's it, Amy. It stands for my x value. And the 3 is my y value. Good, the 3 is my y value. All right. Now, here's what I'm going to do. I'm going to take a ruler and I'm going to draw a line from my origin over here to my dot. Oh no, I missed it. Okay, just make my dot bigger. Okay, there we go. I missed it by a little bit. Just make the dot bigger. Yes, Michael, we did, but I'm going to complicate life just a little bit. Just a little bit. All right. So I know, guys, that if my x value is 4, that means on my x-axis I counted 4 units. So from my origin to my point over here, I counted 4 units. And I know that if I look from here all the way down to my x-axis, my y value is going to tell me that this is 3 units. Okay, that's what my x value and my y value are telling me. This, guys, this over here is my x value. And this over here is my y value. And I can already see Luandile like just flying into it. Right. That's it. Akwando says you can make a circle. You can. And that's because this side over here is called a radius. Okay. Think of this as a rope, guys. If this was a piece of rope and I tied a pencil to the end of my piece of rope, I can actually take this thing and draw a circle around, right? But if I want to know what the radius of my circle is, or the radius of this line is, I can use our trusted friend. Who remembers, how can we find R? I've got this side and I've got this side, and this makes a right angle triangle. What formula are we going to use, guys? Any ideas? Yay! That's it, Nomtando. That's it, Liche. Zamanzini. Excellent. We're going to use Pythagoras. So we're going to use our x value and our y value to find our r value. And so I can already see that, hey, ma'am, what are you doing? It's fine. We're going to start it again on Monday. Don't stress. This is just an introduction. So if we want to find our r squared, we're going to say x squared plus y squared is equal to r squared. It's just that in Pythagoras, we say a squared plus b squared equals c squared. This time, we're just going to use x and y and r. That's the only difference, guys. That's the only difference. Okay, now if we quickly do this, my x is going to be 4 squared plus my y, which is 3 squared. Oh, sorry, ma'am. Sorry. Thank you, teacher. Nels. Teacher Nels was about to kill me. All right, Komoto, finish this off for us, my sweetie. What am I going to get?
Ma'am, I wanted to ask you that don't we put 4 and 3 into brackets?
You can do this 4 squared and 3 squared. It's just that they're both positive. Okay. So
if
we don't need
we
to
put them in brackets.
If they're negative, then put them in brackets. Otherwise, it's going to start a whole drama. Okay. So put them in brackets. Okay, Komoto.
Okay.
All right. Can you give me an answer for R? 16 plus 9 is equal to?
9 is equal to 25.
Good. 25 is equal to R squared. And if I want the square, if I want R, I'm gonna square root, yes?
Square root of 25 is equal to 5.
Good. So R is equal to 5.
25.
Excellent. Yeah. So that means that our R over here is 5. Beautiful. Well done.
And
very
Coco,
nicely done, Komoto.
Why didn't you say plus or minus?
Plus or?
Why didn't you say plus or minus with the radius?
Oh, that's a good question. The reason we don't say plus or minus, teacher Nels, is because I'm looking for the length. And I could never say I walked minus 2 kilometers or the length is minus 5 centimeters. We've never heard of a thing called minus 5 centimeters. It's always going to be 5, positive 5 centimeters. Thanks for that question, teacher Nels. Randile, don't write plus minus. Your radius is always going to be positive, okay? Because the radius is measuring the length, okay? Radius will always be positive because it's measuring the length. Now, as teacher Nels puts the link to the quiz in the chat, I'm going to remind you guys that Jasmine did tell us that this is 0 degrees and that is 90 degrees. And that means that I can use my X, my Y, and my R to find my angle theta. Oh man, what did you just do? Yes, we're going to use our X and our Y and our R to find theta. And Samanzini, you are 100% correct. Okay,